This will be for the Khan exercise, Evaluate Radical Expressions Challenge. All right, they want us to evaluate this fraction here. It's going to be a constant number. There's no variables here. All right, because both of these numbers are 64, we can simply subtract these exponents going down. Okay, so it's the same thing as if the 64 were just an x. So we keep the 64, and we're going to subtract 7/10 minus 1/5. Okay, 7/10 minus 1/5. Now, of course, we have to convert to a common denominator. 1/5, multiply top and bottom by 2. That's going to be 2/10. Okay, so we have 64. 7/10 minus 2/10 is 5/10. And reducing that fraction for the exponent, that's going to be 64 to the power of 1/2. Okay, and actually that's not the final answer. 64 to the power of 1/2 is, of course, the same thing as the square root of 64. So that is just 8. Final answer. Okay, here we have -16, the fifth root of -16 times 2 to the 1/5. Well, let's see, if you multiply -2 5 times, let's see, -2 times -2 times -2 times -2 times -2. Let's see what happens here. 2 times 2 is 4, times 2 is 8, times 2 is +16. Okay, let me see. Okay, I have a better idea. I am going to try to get this, turn this into a 2, so it matches this 2, and then we can just add the exponents. Let's try that instead. Okay, since this is the fifth root of -16, I'm going to break this up. I am going to make it the fifth root of -1 times the fifth root of 16. Okay, since they're the same root, we can multiply these, and together they would be the fifth root of -16. Okay, so I broke that one up, and then I still have the 2 to the 1/5. All right. So let's see, the fifth root of -1 is just -1. If you multiply -1 5 times, you'll get -1. So that is just -1. And the fifth root of 16, I am going to change that to the fifth root, and 16 is the equivalent of 2 to the 4th power. Okay, if you multiply 2 4 times, you'll get 16, and that's times 2 to the 1/5. So now we're in business. All right, -1 and 2 to the 4th. The fifth root is the same as the exponent 1/5. So this is going to be 2. The exponent goes to the numerator, that's 4, and the root goes to the denominator, that's 5, and that's times 2 to the 1/5. Okay, so I just converted this right here to a fractional exponent. We still have -1, and since we have 2 and 2, we can just add the exponents. Okay, we keep the 2. 4/5 plus 1/5 is 5/5. Okay, and that's the same as 2 to the 1st power, which is just 2. So -1 times 2 is just -2. Enter that in the box. So the idea here was to turn this mess into a 2 to a fractional exponent. Okay, this way we could just add the exponents like we did toward the end. Okay, let's see here. We have the third root of negative 54. And I know I could take the third root of negative 27. So I'm going to break this up. Okay, so that's going to be the third root of negative 27 times the third root of positive 2. All right, so I just broke that up. All right, negative 27 times 2 is negative 54, and I have the third root on both of these, so that works. And let's see. I am going to make this a fractional exponent. We're going to have that as 1/2 to the power of 1/3. All right, 1/2 to the power of 1/3. Now, let's see. Third root of negative 27 is just negative 3. Okay, if you multiply negative 3 3 times, you'll get negative 27. This is the third root of 2, so that's going to be 2 to the 1/3. And if I take the reciprocal of 1/2, I can make that a 2, and the 1/3 becomes negative, so that's going to be a negative 1/3. All right, so the idea here, again, was to get the 2's to match, so I can just add the exponents. All right, we have negative 3. We have 2 times 2, you keep that, and here you just add the exponents. 1/3 plus negative 1/3 is actually just 0. Okay, and 2 to the 0 is just 1, so that's negative 3 times 1, which is just negative 3. Okay, again, the idea was to try and get the 2's to match. So since I factored out a 2 out of this negative 45, and I converted the 1/2 to a 2 with a negative exponent, so I was just able to add exponents when I had 2 and 2. All right, here we have 54 again. I'm thinking we're going to do almost the same thing. I'm going to try to turn this into a 2 to match the 2 in the numerator. Okay, so I have 2 to the negative 4/3 in the numerator. And in the denominator, I'm going to break this up. We have 54 to the negative 4/3. I'm going to make that 2 to the negative 4/3 times 27 to the negative 4/3. All right. The exponents match, so I can do 2 times 27 is 54. All right, and now from here, it's not bad. These are all multiplied, so I can cancel 2 to the negative 4/3 over 2 to the negative 4/3. That's gone. Okay, and I can move this up. Since it's a negative exponent, I can just move this, shift the whole thing up to the numerator, and change the plus minus sign on the exponent. So this is just going to be 27 to the power of 4 over 3. Okay, you can have it times 1, but that does nothing. All right, so now I have the third root of 27. Remember, the denominator becomes the root, and that is going to be to the 4th power. Okay, the third root of 27 is just 3, because if you multiply 3 times, you get 27, and that is to the 4th power. 3 to the 4th power is the same as 9 times 9, which is just 81. So to sum it up, with these types of problems, try and get the base number to match. Like we did before, if you have x to the a over x to the b, you can just subtract the exponents. So if you get the 2's to match, you can just subtract the exponents. That's going to be x to the a minus b. And same with the multiplication. If you can get them to match, x to the a times x to the b, then you just add the exponents, x to the power of a plus b. So try to get the numbers to match just like you have the x's matching.